some practice problems on work and power. So for the first item, we are asked to solve for work. How much work is done by a force of 20 newtons that was applied to push a package of 80 meters along the floor. So we are given with 20 newtons. Of course, that is our force applied on the package. The package was displaced 80 meters along the floor. So using our formula for work, work is equivalent to force times the change in position or the displacement. Work is 20 newtons multiplied by 8 meters. Meters times newtons, that's joules. 20 times 8 is 160 joules. So the work done on the package is equal to 160 joules. On question number 2, we are still asked about work. This time, the object of interest is a block which has a mass of 2.0 kilogram or 2 kilograms. And it was accelerated at 5 meters per second squared. Curious, we are given with acceleration with a distance of 0.5 meters, so that's our displacement, across a frictionless table. We are given a hint here. We have to use the force equation to solve for F. Okay. So this is not a straightforward problem. Work is equivalent to force times the change in position or the displacement. You are given with the displacement but not the force. To solve that, we will use the equation we derived from the second law of motion, which is force is equivalent to mass times acceleration. So mass is 2 kilogram, which is the mass of the block. The block accelerated at 5 meters per second squared. So 5 times 2 is 10 kilogram times meter per second squared is newtons. So the force that is needed to be applied on the block with a mass of 2 kilogram for it to accelerate at 5 meters per second squared is 10 newtons. Of course, this is not the final answer. That is only the force applied on the block, 10 newtons. Multiply that with a displacement of 0.5 meters. So what we get is the force times the displacement, which is the work done on the block, equivalent to 5 joules. Okay, next one. Again, we are asked about the work done, this time by a tractor. The object of interest is a large rock with a force of 5,000 newtons. So we are given with the force at 2 meters per second. Okay, this is not acceleration. Meters per second is velocity. Okay, curious again. We are given with a velocity this time for 2 seconds. We are also given with time, but we are not asked to solve for the power. So we might be using the velocity and the time somewhere else, right? Work is equivalent to force times the change in position. We're given with the force. The change in position, the displacement, we are not. And we are given with a hint here to use the kinematic equation number 4. So don't forget your equations. Displacement is equivalent to the final velocity plus the initial velocity divided by 2 multiplied by time. So the final velocity, you're able to move the rock, right? With the velocity at 2 meters per second. Of course, it was at rest at first. So its initial velocity is equivalent to 0 divided by 2 multiplied by time, 20 seconds. Okay. So my displacement will be 20 divide, 2. 2 divide 2 rather is 1 meters per second multiplied by 20 seconds. So my displacement will be, I get to cancel the seconds. 1 times 20 is 20 meters. Okay, 20 meters. Work force is 5,000 newtons, a large force given by the tractor. multiplied by the displacement of 20 meters. So 5,000 times 20, that's 100,000 joules. Or in kilojoules, divide this by 1,000. This will become 100 kilojoules. This is incorrect pala. Okay, now this time, this is a power problem. Calculate the time needed for a 2.5 kilowatt electric motor that performs 75,000 joules of applied work. So our formula for power is work divided by time. But we are asked for the time, so we have to do some manipulation. What can we do first? Let's multiply time on both sides of the equation. In this case, we cancel the time on the right side of the equation. On the left side, we have time times power. But we are only concerned with time. You divide this by power, both sides. So actually, our unit for time, or our formula for time derived from the power equation, will be work divided by power. Work, remember, is in joules. Power is in joules per second. So you cancel the joules, and then you get the reciprocal of 1 over s in the denominator, and the final unit will be in seconds. So time is work, that is 75,000 joules. Power is 2.5 kilowatts. So this time, to convert that to watts, you multiply by 1,000. Or you move the decimal place. 1, 2, 3. Three places to the right, since 1,000 has 3 zeros. Watts. Time will be the quotient of the two, equivalent to 30 seconds. Okay, here's another. Solve the work done by a 500 watt electric mixers in 2.5 seconds. Power is work divided by time. This time you're interested with work. You're given with the power, 500 watts, and the time in minutes, which later on you have to convert to seconds. So multiply both sides by time. Now, work is power times time. Power is 500 watts. Time is 2.5 minutes. I have to convert this to seconds. There are 60 seconds per minute. I can cancel the minute unit. I am left with seconds. Remember, watts is joules per second. So joules per second times seconds from here will be joules, which is the unit for work. 500 rather times 2.5 times 60 will be 75,000 joules, or divided by 1,000, 75 kilojoules. Now here is our answer. Next one. Calculate the power made by a 50 kilogram boy running up the stairs with a height of 3 meters in 2.5 seconds. Okay, so just like the previous problem, power will be work divided by time. We're given with the time, 2.5 seconds, but not the work. So we have to solve for the work. It's force times the displacement. Actually, we can do some modification here. Work is how much work should the boy applied on himself to lift him up the stairs. It should be equal or greater than his weight, or the gravitational force. So let's just say the minimum, which is equal to the gravitational force. We can also change the notation here for displacement, since you are moving upwards, moving along the y-axis. So instead of change in x, we use change in y. How do we compute for the FG? Mass times acceleration due to gravity, 50 kilogram times 9.8 meter per second squared. What's that? 50 times 9.8 490. Kilogram times meter per second is newtons. That's my force. And I need to be displaced. The boy need to displace himself by 3 meters. So what's the product? 1,400 and, oh, wait a minute. Oh, yes, 1,470 joules. Let me verify. 490 times 3. Yes, 1,470 joules. Now I can finally compute for the power. 1,470 joules of the boy, since he climbed the stairs in under, or um, in 2.5 seconds. So 1,470 rather divided by 2.5, 588. 588 joules per second is watts. Okay, I think this is the last one for this set. How many hours will it take for a 500-watt electric drill to work for 100 kilowatt hour? Okay, so we're given with two power here. The other one is kilowatt hour. So we are actually familiar with kilowatt hour. Usually our electricity bills are in um, kilowatt hour. So it's how much kilowatt we use multiplied with the total number of hours we are using the, let's say, appliances, or we are consuming energy. So how do we get hours? They are asking for hours. If we have a watt and a kilowatt hour given. So let's first convert the kilowatt to watt. So 100, if you want to convert that, 100 kilowatt, if you want to convert to watts, will be 100,000 watts. The unit is in watts per, oh no, in watts hour. Kilowatt hour to watts hour. But if we divide this by 500 watts, we can get to cancel the watts and we are left with hours, which is the unit that we wanted in the first place. So doing the division, what we will have is 200 hours. Okay? Next, we will be discussing gravitational potential energy and relative potential energy.